implicit differentiation, part 2. Very similar to the first part. Just going to go through a couple problems, a little bit extra practice if you want it or need it. So the first thing says find all tangent and normal lines to this curve at the x value. And so what we want is for a tangent line, we need a slope and we need a point, x and a y value. We know the x value, root 2 over 2. If you want to find the y value, and there could be more than one when you're looking at implicit differentiation, that's why it's implicitly defined, because you can't solve for y all by itself most of the time, which means there's probably more than one y value at most x values. So when x is root 2 over 2, if we want to find the y values, we use the original curve. Okay? The slope is going to come from the derivative, and we'll get to that, but you might as well just find that y value first, because we know the x value. We can plug that in, then we can find the y value. So let's go ahead and plug in this x value into this equation. You're going to get root 2 over 2 squared, which is 2 over 4, which is a half. So that becomes 1/2 times root 2 over 2 squared again is 1/2 plus y squared equals y squared. Right? I think so. Yeah. Okay. Now we just solve for y. So we get 1/4 plus 1/2 y squared equals y squared, which means 1/4 equals 1/2 y squared, which means multiply by 2 here. So we multiply by 2, we get 1/2 equals y squared. And when you take the square root, you get the positive or negative square root of 1/2 equals y, which is the same exact thing as plus or minus square root root 2. Get out of here. Over 2, like that. So we have 2 points. When x is root 2 over 2, we have y is also root 2 over 2, or we have root 2 over 2, negative root 2 over 2. Okay. Now all we need is a slope, and then we can find the tangent and normal lines. So tangent line is going to have the same exact slope as this function. It's going to be parallel to the function at the point. So we just got to find the slope of this function at that point. So before I derive this, I'm going to multiply in that x squared. It's going to make it a little bit easier for us. So I'm going to rewrite it as x to the 4th plus x squared y squared equals y squared. If you didn't do that and you did all the work out already, you're going to get the same answer as long as you did everything correct. I just think this is a little bit easier to derive. So this is 4x cubed plus product rule 2xy squared plus 2y dy dx x squared equals 2y dy dx. And simplifying this down, dy dx is going to be negative 4x cubed minus 2xy squared. There are all the things without the dy dx moved over. And we're going to divide by 2y, or 2x squared y, minus 2y. That's our derivative. So even though it looks a little bit ugly, we need to find the slope here at these 2 points. So we got to plug this stuff in. So I'm going to erase, let me make sure, just double check my work here. Minus 4x cubed minus 2xy squared. That's all good. 2x squared y minus 2y. Okay. Now we need the slope. So we plug in, let's find the slope at this point first. Root 2 over 2, root 2 over 2. We're going to get, and you write this like this, dy dx, and you put a bar, and then the point. And that means dy dx at root 2 over 2. It's very similar to writing f at x. Okay, so we plug root 2 over 2, we're going to get negative 4 times root 2 over 2 cubed is, you can simplify it down, but that's going to be, what, 2 root 2 over 8, so root 2 over 4. Okay, because this is 1/2. No, 1 over root 2. So when you cube that, 1 over root 2 becomes 1 over 2 root 2 times root 2 over 4. Good. Okay, yeah. Just making sure I'm doing this right. Minus 2 times root 2 over 2, which is root 2, times root 2 over 2 squared, which is 1/2. over 2 times root 2 over 2 squared, that's 1/2, times 2 is 1, times y, which is root 2 over 2, minus 2y is just root 2. So there's our answer right here. We just got to simplify it down. That's going to be negative root 2 minus root 2 over 2, which is 1/2 root 2, over root 2 over 2 minus root 2. And this is just going to be negative root 2 minus root 2 over 2. You get the 2's on the denominator, so it's going to be negative 3 root 2 over 2 over, this is root 2 over 2 minus this, that's going to be negative root 2 over 2. That's a 2. Because this is really, if you don't like this is really 2 root 2 over 2. So 1 minus 2 is negative 1 over 2, and this is really negative 2 root 2 over 2. So when you subtract that, you get negative 2 minus 1 is negative 3. And to simplify this, so I'm running out of room, I'm going to do it over here. We're going to have negative 3 root 2 over 2 times negative, flip it, 2 over root 2. And even though it started out super nasty, these root 2's cancel, these 2's cancel, and we end up with 3. So for our first point, the slope is 3. You can squeeze that in there. Now we need to find the slope of this one. Okay, so got to plug in this second point. So now with this right here is enough information to find the tangent and normal line at this point. But we have to find it at this other point because it says at x equals root 2 over 2, and there's 2 points there. So now we're going to find dy dx at root 2 over 2, negative root 2 over 2. That's going to be, this stays the same. I'm just going to rewrite it here. Root 2, negative root 2 over 2 squared is just positive 1/2. This is going to be negative now. And then this is going to be negative, so this turns positive. Okay, I just turned all the y's negative is all I did. And it will simplify it the same way. 4's cancel, so we're left with negative root 2. Negative root 2 times 1/2 is negative root 2 over 2. That's the same. Over negative root 2 over 2 plus root 2. So this is negative root 2 over 2, or 2 root 2 over 2, and this is 2 root 2 over 2 as well. And that's going to be, we'll finish it over here. Negative 2 minus 1 is negative 3 root 2 over 2 over negative 1 plus 2 is positive 1 root 2 over 2. And multiplying by the reciprocal again, instead of dividing fractions, that's going to be 2 over root 2. And it simplifies out again, nice. Bam, 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 bam. Negative 3. So the slope of this one is negative 3. Okay. So we've got the points and the slopes. So the tangent lines, and I'm going to label them because we're going to have tangent and normal. The tangent lines are just going to be y minus root 2 over 2 equals 3x minus root 2 over 2, and y minus negative root 2 over 2 equals negative 3x minus root 2 over 2. That's tangent lines. The normal lines are very similar. The normal line is the same thing as the tangent line almost. Instead of being parallel to the curve, it's perpendicular to the curve at that point. But since we know the parallel slopes, the parallel slope at root 2 over 2, root 2 over 2 is 3. So the normal line goes to that same point. So it looks like this. But instead of being parallel to it with a slope of 3, it's perpendicular. And the perpendicular slope is just the opposite reciprocal. Flip it and reverse it. Thank you, Missy Elliott. And the other one is going to be flipping this negative 3 and changing this line as positive 1/3. X minus root 2 over 2. So there's tangent and normal. And the difference, like if you have a curve, say like this guy, and we want the tangent line at this point, that's going to look something like this. The normal line goes to the same point, but it's perpendicular. perpendicular, so it makes 90 degrees with the tangent line and the function at that point. Okay, so normal line is the perpendicular one, tangent line is the parallel one. Excellent. Number 2, find the tangent line and normal line to the folium of Descartes. They just give this a name. Descartes was a dude, he did a lot of math back in the day, very intelligent man. He gets this curve named after him. I'm not even sure what a folium is, it doesn't matter. The curve looks something like this dude. Okay, you can tell it's not a function, so we can't rewrite it explicitly. That's fine. And we want it at the point 4/3, 8/3. And in this case, they gave us the x and the y. So we don't have to find the y at all. We just need to know the slope. And we get the slope by deriving it. So we're going to derive it and get 3x squared plus 3y squared dy dx. Minus, I'm going to put parentheses around this because we're subtracting off the derivative of this whole thing here. If you don't put a parenthesis there, you're going to lose a negative. But you're going to get 6y plus 6x dy dx equals 0. And simplifying that down, we get dy dx is equal to negative 3x squared plus 6y over, because we're going to add 6y over to here, and divide by 3y squared minus 6x. There we are. And we're going to use this to find the slope. We know the point, we just need to know the slope of this tangent line. So we're going to plug in 4/3 and 8/3 and simplify down. It's going to be a little bit of work. So it's negative 3 times 4/3 squared. Oh man, my dog is going crazy. Okay, sorry about that. Where was I? Oh, we're plugging in 4/3. 4/3 squared is 16/9 plus 6 times y, and y is 8/3 over 3 times y squared, which would be 64/9 minus 6 times x, which is 4/3. Okay, and that's going to become negative 16 over 3 plus 6 and 3 cancel, so that just becomes what, 2 times 8, 16 over 3 and 9 cancel to become 64/3 minus 6 and 3 cancel again, 3 and 6, 2 times 4 becomes 8. Alright, simplifying this further, 16 is really the same thing as, cross them out for a second, 48/3. So negative 16/3 and 48/3 is 32/3 over, and 8 is 24/3. So 64/3 minus 24/3 is 40/3. Multiplying by the reciprocal, we'll finish this up in this little box here. Give us some room. 32 over 3 times 3 over 40. The 3's cancel, and 8 goes into both of these, so that's just 4/5. Took a little bit of simplification, but there you go. So our tangent line, well, the slope is 4/5. So the tangent line is just going to be y minus the y value, which is 8/3, is equal to the slope, 4/5, x minus the x value, 4/3. And again, label that tangent so you know what that is. And now we want the normal line as well. And that's going to be same exact point, y minus 8/3 is equal, but the slope is the perpendicular slope. So negative 5/4 x minus 4/3.